Hello everyone, my name is Saba and I'm here to teach you a little math. Today we're gonna talk about linear functions and their graphs. When you see an equation with a y and x, that x has no power, or in other words, it has the power of 1, but it is not written here. We don't write the power of 1 for x. It is a linear function. The coefficient of the x in linear functions cannot be 0. But the other term in the linear equations is the constant amount. The constant amount here is shown with the letter b. This amount can be 0, but we always should have the x in our equation to call it a linear function. This term that you can see, we have an isolated y and other terms are in the right side of this equation. We call this form of the linear function gradient intercept form because we can easily with a quick scan say what is our gradient and what is our intercept. And later we are going to talk about the gradient and intercept more, and we're going to see how they can help us graphing the linear function in the questions. Another form of a linear function is the general form. Here we have all the terms on the left side of the equation and we have 0 on the right side of the equation. As you can see, we have a variable x, we have a variable y, and we have a constant term. The letters can be changed in different, videos or courses, but mostly we show the gradient with the letter A or M and the intercept with the letter B. But you can see that here in general form, none of that is true. A, B, or C has different meanings here. Here, C is our constant term, but it is not our intercept. There are some examples with actual numbers here. You can find each function with this look and appearance. You can find it, name it as a linear function. As you can see in all these functions, we have x with the power of 1. The coefficient is different, of course, and you can always turn a general form into a gradient intercept form or vice versa, a gradient intercept form into a general form. For example, in this case, I want to make it as a general form. What is the clue here? We should transfer all of our terms from the right side into the left side, and in right side we have nothing but 0. So when I want to transfer negative 4x, and always remember that our terms are separated by the negative and positive signs. So negative 4x is one term, positive 3 is another term. So we're gonna move them, transfer them to the left side of the equation step by step. First, I want to transfer negative 4x. So I move it to the I move it to the left side. It becomes positive 4x. When we are transferring terms to the other side, we have to change the sign of them. So here we have y plus 4x. Now I want to transfer positive 3. It becomes negative 3 equal to 0. This is our general form of this equation. Here, I want to transform this general form into gradient intercept form. What is our clue here? We have to isolate y on one side of the equation. Okay, I want to keep y on this side and move the other terms to the other side. Or you can keep all the terms here and move y to the other side. So if I do that, the second way, because it's going to be easier and simpler, I keep 2x here, I keep positive 7 here, equal to, now I transfer negative y to the other side, which becomes positive y, or y. You can skip writing positive sign. Okay, when you are switching the sides of an equation, if you don't transfer any terms around, you can just simply switch the sides, switch all of the terms in the right side to the left side, and the same thing for the other ones. For example, here I write the um, equation symbol. Y is on the left side. I'm going to write it on the right side. 2x plus 7 is on the left side. I'm going to write it on the right side. Here is our equation transformed from general form into gradient intercept form. In this figure, you can see all of the lines, a graph of the lines that we can have. We have horizontal line here. We can see vertical line here. Here we have a line. When we are talking about gradient, we always take a look at the lines from left to right. From left to right of the coordinated system. When we are looking at this line from left to right, we can see that the line is going upward. So the gradient of the line that is going upward is always more than 0, greater than 0. But when a line is going downward, when we are looking at it from left to right, the gradient of the line is less than 0. It may be negative. In these three forms, we can figure out what kind of line do we have in here. In the first one, in the first one, the coefficient of the x is always telling us about the gradient. In the first one, the coefficient of the x is -4. Okay, so -4, the gradient is less than 0, so it should be going downward. So this line is like this. The other one, the gradient is 1, so it's more than 0, greater than 0. So this one should be like this. And the last one is also 2, positive, so the line should be like this. Okay, guys, in the next slide, we're gonna learn a lot more about linear functions and their graphs and all of their properties. Please keep up watching the next part of my videos on my YouTube channel, or you can access my website. Thank you.